Hey Champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of exams. So today, students, we will be solving Andhra Pradesh Engineering, Agriculture and Pharmacy Combined Entrance Test, that is EAPCET 2023, 17th May, shift first paper. Okay. So in this particular video, I'll be solving the physics part of the paper. So here we go. The first question of this series, that is question number 81. The number of significant figures in 4.870 m is. So we have to find the number of significant figures. So first of all, this question is from the chapter of units and measurements. Units and measurements. So in this 4.870, all zeros to the right of a decimal point are always significant, as we all know. So the number of significant in this is 4. That is, the correct option is B, 4. Okay. Next question, 82. Among the following velocity versus time graph representing the motion of a vertically projected body is. Okay. So we have to find the correct graph for this velocity time. So this question is from the chapter of motion in a straight line. Motion in a straight line. So among these four options, as we all know, when a body is projected vertically, okay, when a body is projected vertically at maximum height, its velocity becomes 0. Let us say the body is starting from this point A. When it is projected vertically, at when its maximum height, at the maximum height, its velocity becomes 0, and after that it velocity starts increasing in opposite direction. Okay, due to the application of gravitational acceleration G. So the graph which represent this will be, I think the option B is the correct answer. At first, the velocity goes to its maximum height, and at maximum height V becomes 0, and after that it starts increasing but in opposite direction, means in downward direction with the acceleration Z. So the correct option is B. Now next question, 83. The resultant of two vectors A and B is perpendicular to vector A, and the resultant magnitude is equal to half of the magnitude of B. Then the angle between A and B is. So this question is from the chapter of, again, motion in a plane. Okay. Now, according to question, we are given with two vectors, vector A and vector B, and both, and it is perpendicular to vector A, means A and B are perpendicular to vector A. Okay, their resultant. Okay, A plus B is perpendicular to A according to question. Okay, and the resultant magnitude is equal to half of the magnitude of B, means A plus B is equals to half of the magnitude of B. We have to find the angle between A and B. Okay. As we all know, the addition of any two vector is equals to under root of what? A square plus B square plus 2AB cos theta, means the angle between these two vectors, and we have to find this angle theta. Graphically, we understand it like this. Let us say this is vector A and this is vector B. Okay, so we have to find this angle theta between these two vectors. So the formula for the addition of any two vector is given as under root of A square plus B square plus 2AB cos theta, and according to question it is equals to what? 1 by 2 of magnitude of B. So squaring both sides, we get A square plus B square plus 2ab cos theta will be equals to 1 by 4 of b square. So we get a square plus 2ab cos theta plus b square minus b square by 4. Taking it towards the left side, it will be equals to 0. Now solving it, we get a square plus 2ab cos theta plus 3 by 4b square will be equals to 0. Okay, let us say this is equation 1. And since the resultant of these vectors is perpendicular to what? A. So we write a plus b according to question is perpendicular to A now. So A dot A plus B will be equals to 0 since they are perpendicular. So opening the bracket, A dot A plus A dot B will be equals to 0. This A dot A will become A square plus this A dot B. Whenever dot product comes, we write always cos theta in terms of cross product. Okay, if there is A cross B, we always use AB sine theta. But whenever there is dot product A dot B, we always use cos theta. Okay, so it will be A cos AB cos theta. So AB cos theta will be equals to 0. So from here, AB cos theta will be equals to what? Minus of A square. Let us say this is equation second. Okay. Now putting this value of this AB cos theta from equation 2 in equation 1. So we write A square minus 2A square plus 3 by 4 B square will be equals to 0. Okay. So it will become this will become minus of A square plus 3 by 4 B square will be equals to 0. So this A square will be equals to 3 by 4 B square. Okay. From here, A will be equals to root 3 by 2 B. Let us say this is equation 3. Now putting this value of A from equation 3 in equation second, that is AB cos theta equals to minus of A square. Okay. So from equation second, we can write AB cos theta equals to minus of A square means this power cancels this. So we can write B cos theta will be equals to minus of A. Now putting this value of A from equation 3 in equation, let us say this is equation 4. So we write B cos theta will be equals to minus of root 3 by 2B. This B cancels. So we get what? Cos theta is equals to minus root 3 by 2. It means theta is equals to minus of cos inverse or cos inverse minus of root 3 by 2. So we get theta, solving it, we get theta equals to 150 degree. So this is our final answer. So the angle between the given two vectors A and B is equals to 150 degree, means option C is the correct answer. Now, next question 84. At any instant t, the vertical distance y and the horizontal distance x of a projectile are given by 2y equals to 60 minus zt square and x equals to 40. The initial velocity of the projectile is, and x and y are in meters, okay, and time is in seconds. So this question is again from the chapter of motion in a plane. Now we are given the x dimension and y dimension. Okay, so x is given as what? 40 and y is 2y is given as 60 minus gt square. Okay, so if we want to find the velocity of this x dimension, means ux will be equals to dx over dt. So it will be equals to what? 4. Let us say this is equation 1. And we are given 2y equals to 60 minus zt square. So uy means del y over del t. So it will be equals to del by del t of what? 3t minus gt square over 2. Okay, since from here, if we want to find the value of y, so y will be equals to 3t minus 1 by 2 gt square, na? Simply just divide the whole equation by 2. So we get uy as 3 minus gt. Okay, let us say this is equation second. So let us say at time t equals to 0 second, when time t equals to 0, ux is equals to what? This 4 meter per second. And at t equals to 0, uy is what? 3 meter per second. Okay, so the initial velocity means at time t equals to 0, the initial velocity will be u equals to resultant of this ux square plus uy square. So it will be equals to under root of 4 square plus 3 square. So it will become under root of 16 plus 9 means under root of 25. That is 5 meter per second. So initially the initial velocity of the projectile will be 5 meter per second. That is option C is the correct answer. Now next question 85. A lorry is moving on a smooth circular path of radius 50 meter. Okay. Smooth circular path. Radius is given as 50 meter with a velocity V is given as 20 meter per second. The banking angle of the road. Okay, we have to find the banking angle of the road. So this question is from the chapter of laws of motion. Now we are given that a lorry is moving on a smooth circular path of radius 50 meter and velocity is given as 20 meter a second. So since radius is given as 50 meter and velocity is given as 20 meter per second, let us say if theta is the banking angle, so tan theta will be equals to, all we know from the theory part, tan theta is equals to v square over r into g. Okay, so here v is what? 20 square over r is 50 into gravity is 10. So solving it, we get 400 over 500 equals to 4 by 5, means theta will be equals to tan inverse 4 by 5. So this is our correct answer. So option B is the correct answer. Okay. Now next question 86. A body of mass 1 kg is moving with a velocity of 10 meter per second due a constant force on a horizontal rough surface having coefficient of kinetic friction 0.4. If the constant force is removed, the body comes to rest in a time. Okay, we have to find the time at which when we remove the force, the body comes to rest. So we have to find this time t. So this question is from the chapter of laws of motion again. Laws of motion. So according to question, we are given mass equals to what? 1 kg and velocity is given as 10 meter per second. And coefficient of friction UK is given as 0.4. Okay. We know that the force on a body is given as force on the body. Since we are given with the frictional coefficient of friction, so we write F equals to mu k into mg. Okay. And we all know that force is equals to mass into acceleration. So from first and second, this mass into acceleration will be equals to this coefficient of friction into mass into gravity. This mass cancels. So A will be equals to UK into G, and UK is given as what? UK is given as 0.4 and gravity is, let us say, 10. So acceleration will be equals to 4 meter per second square. Okay. Let us say this is equation 3. Now it is saying that if the force is removed, the body comes at rest. So we have to find the time at which the body comes at rest. Let us say at t time, the body comes at rest. So using first law of motion, V equals to U minus AT. So when it comes at rest, so final velocity will become 0. Since it is coming at rest now. So 0 will be equals to Initial velocity is was 10 minus acceleration is what? 4 into time. We have to find this time, t. So t will be equals to 10 by 4. It will be equals to 2.5 seconds. So our answer is 2.5 seconds. Means the correct answer is option A. Okay. Now next question 87. A ball of mass 10 kg is allowed to fall from a height of 10 meter. Okay. After collision with the ground, if 50% of its energy is lost, then the height reached by the ball is. Okay. We have to find the height h at which the ball has lost is 50% energy. Okay. So this question is from the chapter of work, energy and power. Okay. Now we are given in the question mass equals to 10 gram. Okay. Means 0.01 kg. And height is h is given as 10 meter. Okay. Means a body whose mass is 10 kg, it is falling down with a height of h equals to 10 meter, from a height of 10 meter. Okay. And when it hits the ground, its 50% energy gets lost. So we have to find the height reached by the ball. Okay. So when it coming in the downward direction, so potential energy will be equals to U equals to mgh. Okay. So m is what? 0.01 into gravity is 10 and height is 10. So potential energy will be 1 joule. Okay. So when the ball reaches on the ground, then its total potential energy will be converted into kinetic energy when it coming in the downward direction. So kinetic energy will become potential energy will become equal to kinetic energy. It will be 1 joule. So after collision, new kinetic energy will be, let us say k dash will be 50% of k. Okay. So initially it will be half m v1 square. It will be equals to 50%, means 50 by 100 of k. So half m v1 square will be equals to k by 2. It will be equals to 1 by 2 into mass is what? 0.01 into v1 square. v1 square equals to k by 2, means 1 by 2. So from here solving, v1 will be equals to 10 meter per second. Let us say this is equation 1, means when the body is falling in the downward direction, at that time its velocity is 10 meter per second. Okay. Now if s dash be the height attained by the ball, let us say s dash is the height attained by the ball, then we write 0 will be equals to u square equals to v square minus 2as. So it will be equals to v1 square minus 2g h dash using third law of motion. Okay. Using third law of motion, we write 0 equals to v1 square minus 2g h dash. So from here h dash will be equals to v1 square over 2g. It will be equals to 10 square over 2 into 10. So it will be equals to 5 meter. So the height will be 5 meter. That is option C is the correct answer. Okay. Now next question 88. A bomb at rest explodes into 3 pieces of equal masses. If 2 pieces move perpendicular to each other, each with a speed of v, then the speed of the third piece is. So this question is again from the chapter of work, energy and power. Okay. According to this question, let us say this is a bomb and it explodes into 3 pieces. If 2 pieces move perpendicular, let us say one piece moves in the x direction and other piece move in the y direction. Okay. So we have to find if both are moving with speed v. Okay, so we have to find the speed of third piece. Let us say we don't know whether what is the direction of the third piece. So let us say the third piece is moving, let us say in this direction. So we have to find its velocity. Okay, is its speed v dash. Okay, so using the conservation of linear momentum conservation. Okay, conservation. So before momentum before collision must be equals to momentum after collision. So before collision, since it is uh, exploding in three parts, three equal pieces means, and if let us say all three pieces are having a mass m, so initially that mass will be 3m. So 3m into velocity at starting point, it is at rest. So its velocity will be 0 equals to mv1 plus mv2 plus mv3, and v1, v2, v3 with the velocities of these three particles. So 0 will be equals to v1 plus v2 plus v3. Okay, and now according to questions, since these two particles are moving in perpendicular direction having same speed v, so v1 will be equals to v2 equals to v. Okay, so in place of v1, v2, we just write v. So it will be 0 will be equals to, let us say, v in the ith direction means x direction, and v in the j direction means y direction into v3. So plus v3. So v3 will be equals to minus of v iota cap plus v j cap. So finding its magnitude, we write under root of v square plus v square equals to v root 2. So the speed of the third particle will be v root 2. So the correct answer is option B. Okay. So moving on towards next question 89. A body rotating with uniform acceleration about its geometrical axis makes 8 rotations in the first 2 seconds. The number of rotations the body makes in the next 3 seconds is. So this question is from the chapter of system of particles and rotation motion. Okay. So according to question, in the first 2 seconds, it is making 8 rotation. Okay, so according to question, and it is doing uniform acceleration, so omega naught will be equals to 0 and t is equals to 2 second. For t 2 second, number of rotations given 8. Okay, so as we know that omega equals to 2 pi f, and f is inversely proportional to time, so it will be equals to 2 pi into 8 by 2. Since number of rotations in 2 second means frequency will be 8 by 2, so it will be equals to 8 pi radian per second. Now, if alpha is the uniform angular acceleration, okay? If alpha is the uniform angular acceleration, then omega will be equals to omega naught plus alpha into t time. And omega is here 8 pi equals to omega naught will be equals to 0 plus alpha into 2 second. So it will be 2 alpha will be equals to 8 pi, 2 4s are 8. So alpha will be equals to 4 pi radian per second square, means for t equals to 2 second making 8 rotations. Here the uniform acceleration alpha is equals to 4 pi radian per second square. Let us say this is equation 1. Okay, now for next 3 second, because it is asking for next 3 second. For next 3 second, let us say t dash. So time will become the first 2 second plus next 3 second. It means 5 second. So omega dash will be equals to omega naught plus alpha into t dash. So here omega dash will be 2 pi into f dash equals to omega naught is 0 plus alpha into t dash. Alpha is what? 4 pi into t dash is what? 5 second. So from here F dash will be equals to 10 rotations per second. Means in 1 second, it is doing 10 rotation. So in 5 seconds, so in 5 seconds, it will do 50 rotation per second. 50 rotations per 5 second. Na? In 1 second, it is doing 10 rotations. So in 5 second, it will do 50 rotation per 5 second. Okay. So now, since the body makes 8 rotation in first 2 seconds, so number of rotation in next 3 second will be this 50 minus the previous one 8. So it is doing 42 rotations in the next 3 seconds. So our correct answer is 42. Option C is the correct option. Now next question 90. A solid sphere is pushed on a horizontal surface such that it slides with a speed of 3.5 meter per second initially without rolling. The sphere will start rolling without slipping when its velocity becomes. Okay, we have to find the velocity. So this question is again from the chapter of system of particle and rotational motion. Okay, particles and rotational motion. So according to this question, let us say this is a horizontal surface, this is a solid sphere, and this solid sphere is pushed on this horizontal surface such that it slides with a speed of 3.5 meter per second, initially without rolling. Now, when it will start rolling without slipping, we have to find the velocity at that time. So when the solid sphere slides without rolling, at that time we are given V equals to 3.5 meter per second. So at that time the kinetic energy with which it is sliding, it will be equals to half mv square, means 1 by 2 m 3.5 whole square. Okay, let us say this is equation 1. Now, when the sphere starts rolling without slipping, then its kinetic energy will convert into rotational and translational kinetic energy. Okay, rotational plus translational. So now this kinetic energy will be equals to half mv square around center of mass plus half I omega square. Okay. And for a solid sphere, we know that the moment of inertia I is equals to 2 by 5 mr square. So this kinetic energy is 1.1 by 2 m into 3 by 5 whole square. So it will be 1 by 2 m 3.5 whole square. It will be equals to 1 by 2 m v square around center of mass plus 1 by 2 I. I is what? 2 by 5 mr square into omega square. Okay. And we know that velocity around center of mass, it is equals to omega into r. So from here, omega will be equals to vcm over r. So putting this value of omega here, we get 1 by 2 m 3.5 whole square. It will be equals to 1 by 2 m v square plus half into 2 by 5 mr square into v square over r square. Okay. Now this m cancels, 2 cancels. So we get 1 by 2 into 3.5 square equals to v square over 2 plus this will become, okay, don't cut it. Okay, it will be easy to solve it. Don't cancel this 2, just write this as it is 2 by 5 into this r square cancels into v square. Okay, now so this 1 by 2 1 by 2 1 by 2 cancels, so we get 3.5 square. It will be equals to v square plus 2 by 5 v square. Okay, so this 3.5 square, it will be equals to 7 by 5 v square. Okay, so from here we will be equals to 3.5 under root of 5 by 7. So solving it, we get 2.96 meter per second. So the velocity will be 2.96 meter per second, means the correct answer is option A. Okay. Now next question. The mechanical energy of a damped oscillator becomes half of its initial energy in 4 seconds. In another t seconds, its mechanical energy becomes 12.5% of its initial mechanical energy. Then we have to find the value of t, means in this t. Okay, so this question is from the chapter of work, energy and power. G and power. Okay. So the energy of the damped oscillator after time t second will be, let us say, E is equals to E naught e to the power minus kt. Okay, where this k is equals to B over m, and this E naught is the initial energy. Okay, this initial energy is E naught. Okay, initial energy means the energy at time t equals to 0 second. Okay, so from this, according to question, in time t equals to 4 seconds, the mechanical energy becomes half of its initial energy, means we can write E naught by 2 is equals to E naught e to the power minus k into t what? 4 second, so 4k. Okay, this E naught cancels, means 1 by 2 is equals to e to the power minus 4k. Let us say this is equation 1. Okay, now the next statement is, in another t second, its mechanical energy becomes 12.5% of its initial mechanical energy. In next t second, means let us say this next t second will be this 4 second plus next t. So t dash, let us say t dash is equals to 4 plus t second. So the energy becomes E dash equals to 12.5% of its initial energy, means E naught. So we can write E naught e to the power minus k 4 plus t. It will be equals to 12.5% of E naught, means 125 over 100, 12.5 into E naught. So it will be equals to 1 over 8 into E naught. Okay. So this E naught cancels. So we can write e to the power minus k 4 plus t will be equals to 1 by 8. Okay. And since e to the power minus 4k is what? 1 by 2. So 1 from this equation, 1 by 8 will be equals to e to the power minus 4k whole cube. Okay, from equation 1, we can write 1 by 8 equals to e to the power minus 4k whole cube. So this equation will become 4 plus t will be equals to e to the power minus 4k whole cube. So from here we can write minus k 4 plus t will be equals to minus 12k. This k cancel. So we can write, and this minus minus also cancels. So we can write t is equals to 12 minus 4 means 8 seconds. So our answer is t equals to 8 seconds, means option B is the correct answer. Now next question. When an external force with angular frequency omega d acts on a system of natural angular frequency omega, the system oscillates with angular frequency omega d. The condition for amplitude of oscillation to be maximum is. Okay, so this question is from the chapter of oscillations. Since students, we know that the amplitude of oscillation is maximum at resonance condition, means that is at resonance the external force oscillates at same frequency as the natural frequency. Okay, means at resonance time, at resonance condition, the external force oscillate with the same frequency as that of the natural frequency. Thus, omega d will be equals to omega. So the condition for the amplitude of oscillation to be maximum is omega d equals to omega, means option B is the correct answer. Now next question, 93. A uniform solid sphere of mass m and radius a is surrounded by a concentric uniform thin spherical shell of mass 0.5 m and radius is 1.5 a. The gravitational potential energy of a unit mass kept at a distance of 2.5 a from the center is. So this question is from the chapter of gravitation. Now let us try to understand this question as, suppose this is a solid sphere and given that its mass is m. Okay, let us say this is the center O and let us say its radius is a. It is surrounded by a spherical shell whose mass is given as 0.5 m and its radius is 1.5 a. Means the distance from the center O to this is 1.5 a. We have to find the gravitational potential energy at a unit of a unit mass kept at a distance of 2.5 a. Means from center to this point, let us say we have to find the gravitational potential energy at this point P. So this distance is 2.5 a. Okay, so from these given condition, the whole mass, means both of solid sphere as well as the spherical shell, the whole mass is assumed to be concentrated at this point O. So the total effective mass will become m dash equals to this m of the solid sphere plus 0.5 m of the spherical shell. So it will be 1.5 m. Let us say this is equation number 1. Okay. Now we have to find the gravitational potential energy of the unit mass kept at a distance r equals to 2.5 a. So gravitational potential energy will be equals to minus g mm over r. Since it is of unit mass, so this small m will be equals to 1. So we can write potential energy will be equals to minus g and capital M is what? 1.5 m. So we can write 1.5 m over r is what? 2.5 a. So solving it, we get u is equals to minus 3 gm over 5a. This is our final answer. So the correct option is minus 3 by 5 gm by a. So the correct option is option A. Now next question, 94. A cylindrical rod made of aluminum has length 1 meter and diameter 10 centimeter. The rod is subjected to a tensile force of 100 kilonewton. The elongation in the rod is. So this question is from the chapter of mechanical properties of solids. Properties of solids. Okay. Now, according to question, the tensile force is 100 kilonewton and there is a cylindrical rod whose length is 1 meter and diameter 10 centimeter. Okay, and the Young's modulus is given as 70 gigapascal. So Young's modulus will be equals to 7 into 10 to the power 10 pascals. Length is of 1 meter. Okay, and diameter is given as 10 centimeter, means radius will be equals to d by 2. It means 5 centimeter means 5 into 10 to the power minus 2 meter. And tensile force is given as 100 kilonewton means 10 to the power 5 newton. Okay. Since we know that the Young's modulus Y is equals to force over area into original length into elongation in length. And we have to find the elongation in the rod. So delta L will be equals to F over A into L over this Y, Young's modulus. So force is what? 10 to the power 5. Area is what? Pi r square means pi into r, 5 into 10 to the power minus 2 whole square into L. Length is 1 meter over Y is 7 into 10 to the power 10 pascal. Okay, so solving it, we get delta L is equals to 1.81 into 10 to the power minus 4 meter means option D is the correct answer. Now, next question 95. A large open top water tank is completely filled with water. A small hole of diameter 4 millimeter is made 10 meter below the water level. The flow rate of water through the hole is okay. So this question is from the chapter of mechanical properties of fluids. Mechanical properties of fluids. Okay. So in this question, we are given with a water tank which is filled with the water, and in this water tank a small hole is made whose diameter is of 4 millimeter. Okay, so D is given as 4 millimeter, so its radius will be 2 millimeter. 2 millimeter means 2 into 10 to the power minus 3 meter. Okay, and this hole is made 10 meter below the water level, so the height will be h equals to 10 meter, and gravity is given as 10 meter per second square. Okay, we have to find the flow rate of water. Okay, so since we know that the velocity for such type of flow of water is given as v equals to under root of 2gh, so the flow rate will be equals to area into this velocity. Okay, so this will be equals to area is what, pi r square, and velocity is what, under root of 2gs. So just put the values given in the question and we will get our desired answer. So v will be equals to, so this flow rate will be equals to pi into r square. R is what? 2 into 10 to the power minus 3 whole square into under root of 2 into gravity 10 into height h is also 10. So solving it, we get pi 22 by 7 into 4 into 10 to the power minus 6 into 10 root 2. Okay. So it will be 88 into 10 to the power minus 5 into root 2 over 10. So flow rate will be 177.8 into 10 to the power minus 6 meter cube per second, means it will be equals to 1.77 into 10 to the power minus 4 meter cube per second. So this is our final answer. Okay, so among these four options, the option C, that is 1.677 into 10 to the power minus 6 meter cube per second, is the correct answer. So the next question is 96. The phenomena of lowering freezing point of water by application of pressure is known as. Okay, so this question is from the chapter of thermal properties of matter. Thermal properties of matter. Okay, it is asking for the phenomena. So we know that the regulation is the phenomena in which the ice melts to the water below 0 degrees Celsius on the application of pressure and refreezes back to ice on the removal of pressure. Thus the phenomena of lowering freezing point of water by the application of pressure is known as regulation. Okay, so regulation is the correct answer. Now, next question 97. A steel ball of mass 200 gram falls freely from a height of 20 meter and bounces to a height of 10.8 meter from the ground. If the energy lost in this process is absorbed by the ball, the rise in its temperature is okay. So this question is from the chapter of kinetic theory. Now, according to question, loss in potential energy will be the equals to the heat energy absorbed by the ball. According to the question, the energy lost is equals to heat absorbed by the ball, means loss in potential energy will be equals to heat energy absorbed by the ball. Okay, by the ball. So the loss in potential energy will be Potential energy is what? mgh, and loss means mg. The difference in the height means h1 minus h2. The loss in potential energy will be mg h1 minus h2 will be equals to heat energy is what? ms into delta t. So from here delta t will be cancels, g h1 minus h2 over this s. So gravitational will be 10 into height h1 and h2. h1 is 20 meter, h2 is 10.8 meter, means 20 minus 10.8 over s. S is what? 460. Okay, 460. Specific heat capacity given as 460 joule per kg per Kelvin na? So 460. So solving this we get delta T is equals to 0.2 degree Celsius. Okay, so the correct answer is option C. Now next question 98. A work of 166.28 joule is done to adiabatically compress 1 mole of a gas. If the increase in temperature of the gas is 8 degrees Celsius, the gas is, okay, so this question is from the chapter of thermodynamics. Thermodynamics, okay. Now, according to question, delta T is given as, increase in temperature is given as 8 degrees Celsius, okay, and work is given as 166.28 joule, okay. So, and 1 mole of a gas means N is equals to 1. So, work done in an adiabatic process is given as, work done in adiabatic process, it is equals to, we know the formula, W equals to NR into delta T, means change in pressure over gamma minus 1. This gamma here is adiabatic constant, okay? Adiabatic constant. It is different for different type of gases, means for monoatomic gas, gamma value is different. For diatomic, it's different. For triatomic, it will be different, okay? And gamma is equals to basically 1 plus 2 by F. For monatomic, this F means degree of freedom will be 3. For diatomic, this F will be 5. For diatomic, this F will be 6, okay? So this is the adiabatic constant, okay? So work done in an adiabatic process is given as NR delta T over gamma minus 1. So gamma minus 1 will be equals to this NR delta T over W, and number of mole is here 1. R is the gas constant. The gas constant is given as 8.314. So it will be 1 into 8.314 into delta T. Delta T is 8 degrees Celsius. 8 into work done 166.28. Solving this, we get gamma minus 1 equals to 0.4. So gamma will be equals to 0.4 plus 1. It will be 1.4. And this is the correct answer, since for diatomic gas always gamma is equals to 1.4. So this gas is diatomic, okay? So option B is the correct answer. Now next question 99. In a Carnot's engine, as the gas absorbs heat energy from the source, the temperature of the source is, okay. So this question is again from the chapter of thermodynamics. So basically, what is a Carnot engine? In Carnot engine, there is a source which we call reservoir, and there is a sink, okay? And in between source and sink, there is a heat engine. And the temperature of source is always greater than the temperature of the sink. Let us say this is T1, this is T2. So the temperature of the source is always greater than the temperature of a sink, okay? So the question is saying that in a Carnot engine, as the gas absorbed by the heat energy from the source, means this reservoir, then the temperature of the source is. So student, basically in a Carnot engine, there is a source, sink, and our thermal reservoir. A reservoir is defined as a source whose temperature does not change on adding or removing any amount of heat from it. So it is a source of very high energy. Thus, in Carnot engine, as the gas absorbed heat energy from the source, the temperature of the source remains constant. So there will be no change in the temperature as the gas absorbed heat energy from the source, but the temperature is independent of it. Okay, so the correct answer is option C, that is the temperature remains constant. Now next question, the 100th one. If the RMS speed of helium and oxygen are equal, then the ratio of the temperatures of helium and oxygen is. So this question is from the chapter of kinetic theory of gases. Kinetic theory, okay. We have to find the RMS speed, okay. Since we know the direct formula, the VRMS is equals to under root of 3 RT over M. See students, we have basically three formulas. The first one is average velocity. For average velocity, we write under root 8 RT over pi M. For RMS velocity, we write under root 3 RT over M. And for most probable velocity, we write under root 2 RT over M. So it is asking here about RMS speed. So we will use this formula, VRMS equals to 3 RT over M. Since 3 is constant, gas R constant, R is the gas constant, it is constant. So this VRMS basically depends on what? Under root T over M. So by writing it for helium and oxygen, we can find the ratio of the temperatures for helium and oxygen. Okay, for helium. Okay, so for helium, the molecular mass will be 4, and for oxygen, the molecular mass will be 32. So V RMS of helium will be equal to under root T over 4, and VRMS of oxygen will be equals to under root T over 32. Okay, so we have to find helium over oxygen na. So we dividing these two equations, we get VRMS of helium over VRMS of oxygen equals to under root T by 4 and under root T over 32. And according to question, the RMS speeds are equal. Okay, means these two are equal. So under root T by 4 will be equals to under root T over 32. Okay, this is of helium and this is of oxygen. So under root T, now squaring both sides. Okay, squaring both sides. So we get T of helium by 4 will be equals to T of oxygen over 32. So T of helium over T of oxygen will be equals to 4 over 32. It will be equals to 1 over 8. So the correct ratio is 1:8. This is our final answer. Now the next question is 101. The ratio of radii of two wires is 1:2 and the density of their materials are in the ratio 1:4. If same tension is applied to both the wires, then the ratio of speed of transverse waves produced in them is. So this question is from the chapter of mechanical properties of fluids. Mechanical properties of fluids, okay? So according to question, the two wires are, the radii of the wires are in the ratio 1:2. Okay, so R1 ratio R2 is given as 1:2 and densities are in the ratio 1:4. So let us say rho 1 and rho 2 are in the ratio 1:4. Okay, so if same tension is applied to both the wires, then the ratio of the speed of their transverse waves. Okay, so we know that speed of transverse waves, okay? The formula for speed of transverse waves is given as V is equals to under root of T over mu, okay? Since the tension is same, means T1 is equals to T2. So V is directly proportional to 1 over under root of mu. Okay. So now V1 over V2 means ratio of the speed of transverse waves according to question. V1 over V2 will be equals to under root of mu2 over mu1. So it will be equals to, and this mu is what? Under root of m over L. So under root of mu2 over mu1 will be equals to under root of m2 over L2 over under root of, sorry, this is L2, okay, M1 over L1. So we get V1 over V2 will be equals to under root of M2 into L1 over M1 into L2. So it will be equals to under root of what? Mass is what? Density equals to mass over volume. So mass is was density into volume. So here M2 mass will be V2 into rho 2 into L1 over M1 is V1 into rho 1 into L2. So now this V1 over V2 becomes under root of V volume is what? Pi r square area into length. So we can write V2 as pi r2 square into L2 into this rho 2 into L1. And similarly, we can write V1 volume as pi R1 square into L1 into rho 1 into L2. Okay, got it? Now this L2 cancels, L1 cancels, pi cancels. So we get V1 over V2 will be equals to under root of R2 square into rho 2 over R1 square into rho 1. So it will become under root of R2 over R1 whole square into rho 2 over rho 1. And we know that according to question, the R1 over R2 is what? 1 by 2, and this rho 1 over rho 2 is what? 1 by 4. So from here, R2 over R1 will be equals to 2, and rho 2 over rho 1 will be equals to 4. So just putting these values, we get V1 over V2 is equals to under root of 2 square into 4. So it will be equals to 4 into 4 equals to 4. So V1 ratio V2 will be equals to 4 ratio 1. This is our final answer. So the ratio of the speed of the transverse wave will be 4 ratio 1, means the option D is the correct answer. Now next question. The frequency of a light ray is 6 into 10 to the power 14 hertz. Its frequency when it propagates in a medium of refractive index 1.5 will be. So this question is from the chapter of wave optics. So students, whenever the light passes through a medium, let us say this is the incident light, it is the incident light is incident on a medium, let us say its refractive index is 1, and after reflection the light goes in this direction and refracted ray, this is reflected ray, and the refracted ray will go in this direction, let us say this is medium 2. So if we talk about the change in the frequency, so when light ray travels from medium 1 to another medium, there is no change in the frequency. Okay, always remember, whenever a light travels from one medium to another medium, there will be no change in the frequency, means the frequency remains same. So the correct answer is option C, 6 into 10 to the power 14 hertz. Okay, now next question, 103. Two coherent light sources having intensity in the ratio 2x produce an interference pattern. Then the value of I maximum minus I minimum over I maximum plus I minimum will be. Okay, given that the ratio of the intensity. So first of all, this question is again from the chapter of wave optics. Now, according to question, I1 over I2 is equals to what? 2x. Okay. And we know that the intensity is equal to square of the amplitude. Square of the amplitude. So I1 will be equals to K1, where K1 is K is constant into A1 square, and I2 is equals to K into, this is A1, this is A2 square. Okay. So I1 over I2 will be equals to K A1 square over K A2 square. So K cancels. So A1 square over A2 square will be 2x. Okay. So A1 over A2 whole square will be equals to 2x. Okay. So from here, A1 over A2 is equals to under root of 2x. So we get I maximum is equals to A1 plus A2 square as we know, and I minimum is equals to A1 minus A2 whole square. So now, according to question, we have to find I max minus I minimum over I max plus I minimum. So I max minus I minimum over I max plus I minimum. It will be equals to A1 plus A2 whole square minus A1 minus A2 whole square over A1 plus A2 whole square plus A1 plus A2 whole square. Now solving it, we get, okay, taking A2 common, so A2 square will be equals to A1 over A2 plus 1 whole square minus A1 over A2 minus 1 whole square over A2 square A1 over A2 plus 1 whole square plus A1 over A2 minus 1 whole square. Okay. Now this A2 square cancels out each other. So it will be equals to, and A1 over A2 is what? Root 2x. So putting this value, we get root 2x plus 1 whole square minus root 2x minus 1 whole square over root 2x plus 1 whole square plus root 2x minus 1 whole square. Now opening the bracket and solving it, we get 2x plus 1 plus 2 root 2x minus 2x minus 1 plus 2 root 2x over this 2x plus 1 plus 2 root 2x plus 2x plus 1 minus of 2 root 2x. So solving it, we get I max minus I minimum over I max plus I minimum is equals to 2 root 2x over 2x plus 1. This is our final answer. So from the given options, the option C, that is 2 root 2x over 2x plus 1 is the correct answer. Okay. So next question 104. Two charges Q and 4Q are separated by a distance of 6 centimeter. The distance of the point from 4Q at which net electric field is 0 is. Okay. So this question is from the chapter of electric charges and field. Electric charges and field. Okay. So according to question, we are given with two charges. Let us say this is Q and this is 4Q. These two charges are separated by a distance of 6 centimeter. Okay. We have to find the distance of the point from 4Q so that at which the net electric field will be 0. Let us say this is point P and this is the point from the charge 4Q at which the electric field E is 0. Okay, let us say. So if the distance between P and this charge 4Q is x, so this will be 6 minus x. Okay, since we have to find this point P, so for this we will write electric field at point Q due to charge Q will be equals to the electric field due to charge 4q. Okay, so we know that the formula for electric field is equals to 1 over 4 pi epsilon naught q over r square. So for this we write 1 over 4 pi epsilon naught q over r square. R square means 6 minus x square equals to 1 over 4 pi epsilon naught. Q means 4q, charge is 4q over r square means x square. Now solving it, 1 over 4 pi epsilon naught cancels out each other. So we get, and this q also cancels. So we get 1 over 6 minus x whole square. It will be equals to 4 over x square. Okay. Now solving it, we can write it as 1 over 6 minus x square equals to 2 over x square. Okay, so we can write it as 1 over 6 minus x will be equals to 2 over x. Now solving it, x equals to 2, 6 minus x, so it will become x equals to 12 minus of 2x. So 3x will be equals to 12, so x will be equals to 4. So this distance x is 4, means the point P will be 4 centimeter from the charge 4q such that the net electric field is 0. So the correct answer is option D, 4 centimeter. Now next question 105. Inside a charged hollow sphere at any point the electric field E and potential V are. Okay, this question is again from the chapter of electric charges and field. Electric charges and fields. Okay, now since it is asking about the charge hollow sphere, so if we are asked about the charge hollow sphere or about the spherical shell hollow sphere, if the question is asking about hollow sphere or spherical shell or a conductor, okay, for these three cases the electric field E will be 0 inside the hollow sphere. So inside a charged hollow sphere the electric field is 0, and since we know that E is equals to minus of delta V, since E is 0, so for this V become constant. Okay, so the correct option is B, that is V is constant and E is 0. Okay, now next question 106. The equivalent capacitance between A and B in the given figure is. So this question is from the chapter of electrostatic potential and capacitance. Okay, electrostatic potential and capacitance. So now in this figure, okay, if for the given circuit diagram, we have to find the equivalent capacitance between A and B. Okay, so if we considered as the balanced Wheatstone bridge network, okay, considering it as balanced Wheatstone bridge network. So for this, every 1 microfarad capacitor is useless. Okay, all these 1 microfarad between this point A and B are useless. So our network circuit diagram will become as like this. This will be of 1 microfarad, 3 microfarad, 9, 27, and so on. And this is point A, and this will be again of 1 microfarad. This is of 3 microfarad, 9 microfarad, and 27 microfarad, up to so on. And this is point B. Okay, so for solving this circuit network, first of all we have to find the capacitance of these 4 capacitors and then the capacitance of these 4 capacitors. Since these 4 capacitors these are connected in series. So for this, let us say the capacitance here is C1 dash and here the capacitance is C2 dash. Okay, so for C1 dash, since these are connected in what series, so for series 1 over C1 dash will be equals to 1 over 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 up to so on. So it is like this: 1 over 1 plus 1 over 3 plus 1 over 3 square plus 1 over 3 cube up to so on. So it will be solving this series, so it will be 1 over 1 minus 1 by 3, so it will be 3 by 2. So 1 over C1 dash will be 3 by 2, so C1 dash will be 2 by 3 microfarad. Okay, let us say this is equation number 1. So the net capacitance of these four capacitors, C1 dash, comes out to be 2 by 3 microfarad. Now similarly, these are all same, 1, 1, 3, 9, 27, like in this. So its equivalent capacitance will be also 2 by 3 microfarad. Okay, so C1 dash is 2 by 3 microfarad. Similarly, C2 dash will be 2 by 3 microfarad. Let us say this is equation second. And now these two combinations means C1 dash and C2 dash, these are connected in parallel. So for parallel combination, we know that C equivalent will be C1 dash plus C2 dash. So it will be 2 by 3 microfarad plus 2 by 3 microfarad. So it comes out to be 4 by 3 microfarad. So our correct answer is option D, 4 by 3 microfarad. Okay, now next question, 107. Two metal wires of same length, same area of cross section have conductivities of their material sigma 1 and sigma 2. If they are connected in series, the effective conductivity is. So this question is from the chapter of current electricity. Current electricity, okay. Now, according to question, there are two wires and they are connected in series. Since we know that the wire are always in the cylindrical form, so since they are connected in series, so they will look like this. And they are having length L1, let us say length L2, and area, let us say area is A1 and area is A2. According to questions, they have same length, means L1 equals to L2 equals to L, and area is also same, equals to A, and its conductivity is sigma 1 and its conductivity is sigma 2. We have to find the effective conductivity when they are connected in series. So we know that the resistance formula for series combination R is equals to R1 plus R2, and we also know that R is equals to what? Rho L by A. The relation between conductivity and resistance is R equals to rho L by A. So we can write for R equals to R1 plus R2. So we write rho L1 plus L2 over A equals to rho 1 L1 over A1 plus rho 2 L2 O2 A2. So it will be rho, since L1 and L2 same length, so L plus L over A equals to rho 1 L over A plus rho 2 L over A, since area and lengths are same according to question. Okay, so this will be 2 rho L over A will be equals to L over A taking common rho 1 plus rho 2. Okay, so it will become L cancels, A cancels, so 2 rho will be equals to rho 1 plus rho 2. So we write 2 over sigma. It is equals to 1 over sigma 1 plus 1 over sigma 2, since rho is equals to 1 over sigma. Okay, now we can write 2 over sigma will be equals to sigma 1 plus sigma 2 over sigma 1 into sigma 2. So sigma will be equals to 2 sigma 1 sigma 2 over sigma 1 plus sigma 2. So this is our final answer. So from this, the option number B, that is 2 sigma 1 over sigma 1 plus sigma 2 is the correct answer. Okay. Now next question 108. In the circuit, the cells are having negligible resistances. If the galvanometer shows null deflection, then the value of V is. Okay. So this question is again from the chapter of current electricity. Sorry, this again from current electricity. Okay. Now, according to this question, if the galvanometer shows no deflection, okay, means here the value of current I will be 0 according to question. Okay. Now, this circuit diagram will look like this is 500 ohm. This is of 12 volt, and here is a resistance of 100 ohm, and here will be a galvanometer, and this is voltage V. Okay. Now, using Kirchhoff's voltage law, we will use Kirchhoff voltage law. Let us say this is loop L1, this is loop L2. Current I1 is flowing in this direction and current I2 is flowing in this direction. Okay. So for loop L1, okay, applying Kirchhoff's law in loop L1. So for L1, if current is flowing in this direction, so we can write minus of 12 plus 500 into I1 plus this 100 I1 minus I2. It will be equals to 0. So solving it, we get minus 12 plus 500 I1 plus 100 I1 minus 100 I2. It will be equals to 0. So this will become 600 I1 minus 100 I2 will be equals to 12. Let us say this is equation 1. Okay. Now using Kirchhoff voltage law in loop 2. So for loop 2, we can write this 100 I2 minus I1. This 100 I2 minus I1 plus this I2 into this RS. Okay. I2 into this RS plus V will be equals to 0. So since we know that according to question, the galvanometer shows no deflection. No deflection means here in this galvanometer, the current that is I2 which is flowing through it, it will be 0 for loop 2. So solving it, we get I2 equals to 0. So we get from here V is equals to, sorry, this will be equals to minus of 100 I1 plus V equals to 0. Okay. So putting the value of I2 equals to 0 in equation 1, we get 600 I1 equals to 12. So I1 will be equals to 12 over 600. So it will be equals to 1 over 50 ampere. Let us say this is equation 2. Okay. I1 equals to 1 over 50 ampere. So now putting the value of I1 in, let us say this is second, this is third. Putting the value of I1 in the equation second, so we get 100 I0 minus 1 over 50 plus this is 0 plus V equals to 0. Okay. So we get V is equals to 100 I1 means 100 into 1 over 50 equals to 2 volt. So the value of V here is 2 volt. Okay. So option D is the correct answer. Now question 109. If Q is the electric charge, B is the magnetic field, R is the D radius, and M is the mass of ions, the kinetic energy of ions in cyclotron is given by. Okay. So this question is again from the chapter of moving charges and magnetism. Moving charges and magnetism. Okay. So, according to question, if v is the speed of the ion in circular orbit, okay? If v is the speed of the ion in circular orbit, so we know that the relation BQV is equals to what? mv square over r. So from here, v will be equals to BQR over m. And so the kinetic energy of the ions in cyclotron will become what? Kinetic energy is equals to half mv square. So it will be equals to half m, and v is what? BQR over m square. So it will become, kinetic energy will become half this 1m cancels, so it will become 1 by 2 b square q square r square over m. Okay, so from this the correct option is option the correct one is D, q square b square r square over 2m. Okay, now next question 110. Curl the palm of your right hand around the circular wire with fingers pointing in the direction of the current, and the thumb gives the direction of the magnetic field. In this case, the upper side of the loop may be thought of as, okay. So this question is from the chapter of moving charges and magnetism again. Moving charges and magnetism, okay. So according to question, let us say this is a circular wire, okay. There is a circular wire. Wire is always in the form of a cylinder, okay. If let us say this is our hand, this will look like this. If, okay, if according to question, according to right hand thumb rule, okay, using right hand thumb rule, when curl the palm of right hand around the circular wire with the fingers pointing in the direction of current. If the fingers are pointing in the direction of current, the thumb gives the direction of the magnetic field. In this situation, current in the upper side of the loop will be in the anti-clockwise direction. Okay, so the current will be in anti-clockwise direction. Okay, and hence the upper side of the loop may be thought as the north pole. So the correct option is option D, that is north pole. So the next question is 111. The Curie temperature Tc represents. So this question is from the chapter of magnetism and matter. Magnetism and matter. Okay. The question is asking about the Curie temperature Tc. First of all, student, the Curie temperature Tc, it is the temperature at which the magnetic materials, the magnetic material loses their magnetism. Okay. It means at Curie temperature, the ferromagnetic substances become paramagnetic substances. The Curie temperature is related to the susceptibility chi, and it is equals to 1 over T minus Tc, means when the this is temperature T equals to Tc, and this is temperature T greater than Tc, means when the temperature becomes greater than the Curie temperature, the ferromagnetic material changes to paramagnetic materials. Okay, means at Curie temperature, the ferromagnetic material gets converted into paramagnetic material. So Curie temperature represents temperature of transition from ferromagnetic to paramagnetic. So among these four options, the option C is the correct answer. That is temperature of transition from ferromagnetic to paramagnetic. Okay. Now next question 112. Physically, the self-inductance plays the role of. Okay. So this question is from the chapter of electromagnetic induction. Electromagnetic induction. Okay, it is asking about self-induction. So physically the self-induction plays the role of inertia, means it is the electromagnetic analog of mass in mechanism. So work needs to be done against the back EMF in establishing the current. Okay. So the self-induction plays the role of inertia. That is option A is the correct answer. Now next question 113. A resistor of 100 ohm, an inductor of 25 over pi square millihenry, and a capacitor of 0.1 microfarad are connected in series to an AC source. The impedance of circuit is minimum for a frequency of. Okay. So this question is from the chapter of alternating current. Okay. So according to question, we are given with a resistor of R equals to 100 ohm, inductance L equals to 25 over pi square millihenry. It means 25 over pi square into 10 to the power minus 3 Henry. Okay. And capacitance C is given as 0.1 microfarad. C equals to 0.1 microfarad means 0.1 into 10 to the power minus 6 farad. So it means 1 into 10 to the power minus 7 farad. Okay. So it is asking about the impedance of the circuit. So impedance of the circuit is minimum at what? At resonance frequency. Impedance is minimum at resonance frequency, which is given as F naught is equals to 1 over 2 pi under root 1 over LC. Okay. Impedance is minimum at resonance frequency, and this resonance frequency F naught is equals to 1 over 2 pi under root LC. So just put the values given in the question. It is equals to 1 over 2 pi under root L. L is given as 25 over pi square into 10 to the power minus 3, and C capacitance is 1 into 10 to the power minus 7 farad. So solving it, we get 1 over 2 pi into 5 over pi into 10 to the power minus 5. So it will be equals to 10 to the power minus 4 hertz, means the resonance frequency F naught will be equals to 10 kilohertz. Okay. So this is our final answer. Resonance frequency F naught equals to 10 kilohertz. It means option B is the correct answer. Now next question 114. The electric field in Newton per coulomb of an electromagnetic wave is E equals to 36 root pi sine omega t minus kx. The average energy density of the electromagnetic wave due to the electric field is. Okay. So this question is from the chapter of magnetic induction. Okay. Now, according to question, we are given with the electric field E equals to 36 under root pi sine omega t minus kx. First of all, comparing with the standard equation, that is E is equals to E naught sine omega t minus kx, where E naught is the amplitude of this wave. So E naught is given as 36 root pi. Okay. E naught is 36 root pi. Omega is the angular frequency and k is the wave vector. Okay. Wave vector. Okay. Now it is asking about the average energy density. Okay. So average energy density of the electromagnetic wave due to this electric field is given as, its formula is 1 by 4 epsilon naught E naught square. Okay. Where epsilon naught is the permittivity of the free space and its value is equals to uh its epsilon naught value is 8.854 into 10 to the power minus 34 Newton per coulomb. Okay. Sorry, 34 or 32 something. Okay. Now, so UE will be equals to 1 over 4 into epsilon naught into E naught square. E naught square means 36 into root pi whole square. Sorry, it is minus 12. Okay. E naught epsilon naught equals to 8.854 into 10 to the power minus 12 Newton per coulomb square. Okay. Now, so it will be 1 by 4 into epsilon naught 36 root pi whole square So this will be equals to 1 over 4 and this epsilon naught. Okay, multiplying the numerator and denominator with 4 pi. Let us say 4 pi epsilon naught over 4 pi into 36 root pi whole square. Okay, and we know that 1 over 4 pi epsilon naught is equals to 9 into 10 to the power 9 as given in the question also. 1 over 4 pi epsilon naught equals to 9 into 10 to the power 9 Newton meter square plus over Coulomb square. So we will write this value of 4 pi epsilon naught as 1 over 4 into 1 over 9 into 10 to the power 9 into this 4 pi into 36 into 36 into pi. So it will be equals to 4 16 pi. So it will be 1 over 16 pi into 1 over 9 into 10 to the power 9 into 36 into 36 into pi. Okay. So this will become pi cancels it. 9 fours are 36, 4 fours are 16, 4 nines are 36. So it will be equals to 9 into 10 to the power minus 9 joule per meter cube. So the average energy density value comes out to be 9 into 10 to the power 9 joule per meter cube. Okay. So among these four, none of the answers matches. Okay, so maybe the options are incorrect, but the correct answer is 9 into 10 to the power minus 9 joule per meter cube. Okay, now next question 115. When light of wavelength lambda incidents on a photosensitive material, photoelectrons are emitted. If the wavelength of the incident light is reduced by 50%, the maximum kinetic energy of the emitted photoelectrons becomes 3 times the initial maximum kinetic energy. We have to find the work function of the material. Okay, so this question is from the chapter of dual nature of radiation and matter. Okay, of radiation and matter. So, okay. So first of all, according to the first condition, that is wavelength of the light is reduced by 50% when light of wavelength lambda incidents on a photosensitive material. So we know that from the photoelectric phenomena, photoelectric effect, what happens when a light of sufficient frequencies, let us say its wavelength is lambda, a photon is coming whose wavelength is lambda, and it falls on the surface of the metal such that when it hits the surface of the metal, so after that the electrons are emitted from the surface and these electrons are called photoelectrons. Okay. Now, for this photoelectric effect, condition is given as the kinetic energy, means the maximum kinetic energy with which these electrons are emitting from the surface of this metal. The maximum kinetic energy is equals to initial kinetic energy, means Hc over lambda minus phi naught. This phi naught is the work function. Okay. This phi naught is called the work function. So K maximum is equals to Sc over lambda minus phi naught. And according to question, the wavelength of the incident light is reduced by 50%. Okay. Means the wavelength, means the photon with whose wavelength is lambda. Now its wavelength is reduced by 50%. Means lambda dash now will be equals to 50% of lambda, that is lambda by 2. Okay. And now the K maximum for this condition becomes it will be equals to what? 3K maximum. Okay, since when the wavelength is lambda, at that time K maximum is equals to Sc over lambda minus phi naught. Now the wavelength is reduced 50% of the original wavelength lambda. So now this wavelength becomes lambda dash now becomes lambda by 2. So for this lambda by 2, the K dash maximum becomes 3K maximum. So for this K dash maximum will be equals to Hc over lambda dash minus phi naught. Let us say this is equation 1 and let us say this is equation 2. So K dash maximum will be 3 times the initial maximum kinetic energy, na? So when lambda dash is equals to lambda by 2, at that time K dash maximum becomes 3K maximum. So replacing this K dash maximum with 3K maximum, it will be equals to at HC over, in place of lambda dash, we will write lambda by 2 and minus of phi naught. Okay. So this 3K maximum will become 2HC over lambda minus phi. Now let us say this is equation 3. Now dividing this equation 1, what K maximum equals to HC over lambda minus phi naught, dividing this equation 1 by equation 3, that is 3K maximum equals to 2HC over lambda minus phi naught. So we will write dividing equation 1 by equation 3. Okay. So we will get K maximum over 3K maximum. It will be equals to HC over lambda minus phi naught over 2HC over lambda minus phi naught. Now solving it, we get this K maximum cancels. So we get 2HC over lambda minus phi naught will be equals to 3HC over lambda minus 3 phi naught. So this 2 phi naught will be equals to 3HC over lambda minus 2HC over lambda. So now this phi naught will become HC over 2 lambda. So for this new kinetic energy, means when the maximum kinetic energy becomes 3 times the previous kinetic energy, for this the work function phi naught now becomes HC over 2 lambda. That is option B is the correct answer. Now next question 116. The total energy of an electron in an orbit of hydrogen atom is E. The potential energy of the electron in the same orbit is. So this question is from the chapter of atoms and nuclei. So according to question, when the electron is in the orbit of hydrogen atom, at that time its total energy is given as E. We have to find its potential energy in the same orbit. Okay. We know that the total kinetic energy will be equals to the total energy, and it is equals to 1 by 2 times of the potential energy, means the potential energy is equals to 2 times of the total energy. Okay, so when the total energy is given as E, so at that time the potential energy will be equals to 2E. Okay, so the correct answer is option C. Now next question 117. The positron is the antiparticle of. Okay, so this question is again from the chapter of atoms and nuclei. We have to find the antiparticle of the positron. Okay, so positron is the antiparticle of the electron. The antiparticle is positron. Okay, it is because when they annihilate and disappear, giving off 2 gamma rays in process, that is particle appears to have vanished and all the energy is transmitted to gamma rays. So the antiparticle of positron is electron. Okay, so option B is the correct answer. Okay. Now next question. Okay. In the given So the next question is 118, and in the given circuit when A equals to 1, B equals to 1, the values of X and Y respectively are. Okay, so this question is from the chapter of electronic devices. Okay. Now in the circuit diagram, this is a AND gate. This is also an AND gate. This is a NOT gate, means inverse gate, and this is OR gate, means addition. AND gate, what AND gates do, it is just multiply the digits. Okay, means If there is 1.1, it will be 1, 1.0 will be 0, 0.1 will be 0, 0.0 will be 0. And what OR gate does? OR gate just the basic addition, means 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 will be 1, and 1 plus 1 will be 1. Okay. And what this NOR gate does? This NOR gate just inverts the input. Okay, means 1 bar means 0, 0 bar means 1. Okay, now here it is A and here it is B. Since it is an AND gate, so it will do the product of it, means A dot B. Here it is B and here it is A. Since it is a AND gate, so at this point we will get A, B dot A, means A dot B, whatever. But here it is a NOT gate, so for NOT gate we will get A dot B whole bar, means NOT gate. What is does it does just inverse the input now, so we will get A dot B bar. So at Y, what we will get at Y? At Y we will get this A dot B plus this A dot B bar. Okay, so it is asking for the values of X and Y. So for X, A dot B bar means it is X. So for X, A dot B bar, when A equals to 1 and B equals to 1, so X will be equals to 1.1 bar. 1.1 means 1 bar, and 1 bar means 0. So we will get the value of X is 0. Now for Y means A dot B plus A dot B bar when A equals to 1 and B equals to 1. So putting the values 1.1 plus 1.1 bar. So it will be 1.1 is what? 1 plus 1.1 means 1 bar. So 1 plus 1 bar is what? 0. So 1 plus 0 will be 1. So we will get X equals to 0 and Y equals to 1. So C 0, 1 is the correct option. Okay. Now next question 119. In a transistor amplifier, the voltage gain is, okay, so this question is from the chapter of communication system. Okay. It is asking about the frequency response curve, means for a transistor amplifier, this will be the frequency response curve, means if this is frequency F1, if this is frequency F2, so this F2 minus F1, this will be the bandwidth of this frequency response curve, and in the y-axis we'll get the gain. Okay, means voltage gain. Okay, now for this frequency response curve of the transistor amplifier, we see that the voltage gain of the transistor amplifier is constant at the mid of the frequency. Okay, it is constant at the mid of the frequency, means from F1 to F2 the voltage gain is constant, and it is low at the low frequency and high at the, it is low at low and high frequencies both. Okay, so the correct option is option B, that is low for the high and low frequencies, and it is constant at the mid frequency, means option D is the correct answer. Okay, now next question 120. The radio horizon of the transmission of an antenna placed on the 20th floor in a shopping mall where the height of each floor is 2 meter is, okay, so this question is again from the chapter of communication system. It is asking about the what? Radio horizon of the transmission of an antenna. Okay, so according to question, the height of the antenna, height of antenna H, it will be equals to height of each floor, height of each floor into number of floor. Okay, this is the formula for finding the height of the antenna, that is height of each floor into number of floor. So it will be equals to what? Height of each floor is 2 meter and the number of floor is what? 20 floor. So it will be 40 meter. Okay, this we will get the height of the antenna. Now for this, the radius of the earth. Radius of earth R is given as 6.4 into 10 to the power 6 meter. Now the radius of the horizon will be, radius of horizon will be equals to under root of 2RH, means under root 2 into R, 6.4 into 10 to the power 6 into H. H is what? 40 meter. So we'll write 40 here, okay? So solving it, we get 22.6 into 10 to the power 3 meter. So this comes out to be 22.6 kilometer, okay? So the correct option is option A, that is radius of the horizon is 22.6 kilometer.